Hello everyone, Aaron here. Welcome back to Leetcode. Today we are doing the Pacific Atlantic water flow problem. There is an n by n rectangular island that borders both the Pacific Ocean and the Atlantic Ocean. Okay, maybe this is the mythical Null Island. That's off the coast of Africa. The Pacific Ocean touches the island's left and top edges, and the Atlantic Ocean touches the island's right and bottom edges. Pacific, Atlantic. The island is partitioned into a grid of square cells. You are given an n by n integer matrix heights, where this tells us the height of that particular region above sea level. The island receives a lot of rain, and the rainwater can flow to neighboring cells directly north, south, east, and west if the neighboring cell's height is less than or equal to the current cell's height. Water can flow from any cell adjacent to an ocean into the ocean. So we immediately know this one must be able to go here. The question is whether it could also go to the other side. These this corner and this corner must always be able to get to both. The island return a 2D list of grid coordinates result, where result I row column denotes that rainwater can flow from cell row column to both the Pacific and Atlantic Oceans. So here, for example, these corner ones must always do that. These ones must always be able to reach there, but there's a chance they could run, I guess, up that way. This is partly an all pairs shortest. No, it's not an all. It's not a shortest path. I don't care about the shortest path to get there. It could meander over the whole map. There's something going on here. So I can start with these two corners, and then what I want to do is sort of work my way out from those corners along these edges at least. Now these edges are straightforward, so 1 can't flow up to 5, but it can obviously flow out into the Atlantic Ocean. 6 can flow down to 5, so it can flow down to the Atlantic Ocean, and it borders the Pacific Ocean. So this one can also do 2 different outputs. So if we see that one, this is row 0, 1, 2, 3, column 0. Yeah, so here we can see exactly that. It can flow immediately into the Pacific, but it can also flow out into the Atlantic Ocean. So the edge is fairly straightforward. Start in these corners, check these guys here. And then I think there's something recursive happening, because then we can start the next ring. And again, we want to, well, I don't know where we want to start actually. But what we do definitely want to do, wherever we decide we should start, is we should check all of the places around it to see where it can flow, and then see how many it can flow into. Yeah, that's it. So the corners automatically start with 2. The edges, if their neighbor can flow to 2, they can flow to 2, and their neighbor is lower. That's always a condition we have to check. If the neighbor is lower and the neighbor can flow to 2 places, then we can flow to 2 places. Otherwise, we can only flow to 1. That's what it means to be an edge tile. The inner ring does something a bit more simple. It says, well, I think we want to start at the lowest point on the ring and then just walk around the ring. Is that correct? Yeah, because we need to... I'm just trying to think. If this was a 5 and this was a 4, it's quite hard to know the order to propagate out the information here, because things could turn. One easy solution is to just keep iterating until it's stabilized. So immediately set everything to 1. It can flow into one ocean apart from these corners. No, let's say it slightly differently. The ring, okay. How do I want to do this? I'm just going to calculate the sum of the array. Flow counts sum. Flow sum is the initial matrix of the heights. Let's say prev sum equals -1, while flow sum does not equal prev sum is equal to the flow sum. Flow counts flow sum is equal to self dot update flows flow count heights, and then so assume this iterates until this is stabilized and we know the counts of everything. So we know this flows into two things. And then what we want to do is result is an empty array for row in range len heights for col in range len heights. This is, oh, it's not square. If flow counts row col is equal to 2, result append row col. Return result. So this just iterates through the final matrix, which will have stabilized to say how many oceans each cell can flow to. Then we just say if it can flow to 2 oceans, great. Update this. Otherwise, we're done. So initial matrix for the heights. What we want to do is I want to have 0 times len heights 0. Oh no. Hang on, let's quickly change this. If len list, so if len heights is equal to 1, or len heights 0 is equal to 1, So if it's a perfect row or a perfect column, then everything can flow to both sides. I'd love a go-to here. Let's do this. So check for the trivial ones. Not trivial. So check flows. This trivial one, we don't have the flows, obviously, so, but we know all of them are. Two oceans. So, here what I want to do, I want to do one. I want to do a row of all ones. What the heck, let's just do them all zeros. In range len heights. So this is an all zeros matrix of the same size as the height matrix. Then what I'm going to do is for call in range len height 0 matrix 0 call equals 1 matrix len height minus 1 equals 1. So the top and the bottom both get set to 1s for row in range len heights. But I don't need to do the top and the bottom, because I've already done those. Matrix row 0 equals 1 matrix row, in fact I can cut off the corners here as well. Len heights 0 minus 1 equals 1. And then finally mat 0 0 is equal to sorry, my brain wandered for a second there. 2, no, not 0 2, it's 0 len heights 0 len heights 0 minus 1, and then matrix of len heights minus 1 0 equals 2 return matrix. So this now sets up our ring of 1s with 2s in those corners. Def update flows self flow counts heights. So what I want to do is a matrix is equal to 0 times heights 0 for underscore in range len heights. And now what we want to do is for row in range len heights for call in range len heights what we want to do is check the neighbors up. If row is greater than 0, up equals match row -1 column, else up equals none. If row is less than the length of heights -1, down is matrix of row +1. Whoops, what am I doing? Row -1 column, row +1 column. Yeah. Else none. Oh, this is just tedious bookkeeping. If col is greater than 0, left is row column -1, else left equals none. If col is less than len, heights 0 -1, right is row col +1, else right none. Okay. That's awful. There's got to be a better way to do that, but I don't know what it is. Now, let me think about this. So, if up is a coordinate and heights up 0, up 1 are less than or equal to heights row column. Let's do this the other way. So if the up direction isn't worth considering, so here we look at the up thing, its height is too high. We just don't need to consider it at all. If down and height down 0, down 1 are greater than heights row column, equals none. Probably do that here. Let's do that up there. So this is no longer up 0, up 1. This is row -1 col. If heights row +1 col is greater than heights row col, else none. If heights row col -1 is greater than heights row col, else none. So these checks are now the wrong way around. We want that to be less than or equal to, less than or equal to, less than or equal to. If heights row col +1 is less than or equal to heights row col, else none. So now we have up if the up place is valid and downhill from... No, I want to check what's uphill. If this is uphill, if water will flow from here to here, we want to keep it. Ooh, sneaky, sneaky. So, mat row call is the max of low count row column plus flow count I column R C for R C in, let's call it P0, P1 for P in up, down, left, right, if P is not none. Ugh. So we collect all the neighbors, and then we take the largest flow count. So this one can flow to 2 places. So this one here, well, we're not gonna, so if we look, okay, let me say that again. Let's say we're looking at this 6. Its current flow count is 1. The neighbors it could be receiving water from up, well, no, it can't receive water from a 2. It can't receive water from here. It can't receive... No, I've got this wrong. It's the place it can flow to. I did want these the other way around. If it can flow there, so it can flow there, it cannot flow there. That one doesn't count. It can flow there. So if we go here, well, the flow counts as still 1. But if we flow here, the flow counts as 2. This is the way we want it to flow. So that's why we take the maximum. But I promised I was going to return 2 things. So that's what I'll do. This line here just adds up all the values in the array. In theory, once we've found the maximum places each cell can flow, the sum won't change anymore. Let's test it. I don't love this solution, to be honest. Matrix is not defined. That's because it's just mat. Let's use both test cases while we're here. Int object does not support item assignment. What? Oops. I should have a call on the end of it. is going on? Flow count is... Oh, plurals. Sorry, I'm blind. Wrong answer. I think what I want to see here is the flow count and flow sum at every point. Oh, my initial one is wrong. Let's just fill in the whole thing. That's correct, that's correct, that's correct, that's correct, that's correct. Okay, first flow is good. Second one, that's good. That's good. Is that good? So those haven't changed. We should have ended up with a new one. Yeah, you changed, which is good. I think we're just stopping too early. But no. If we stopped too early... Why was 1-3 not found? 1, 1, 2, 3. This one here. What's the root? Sorry, this one here. So the 4 can connect to the 4. Oh, I need to be more clever than this. What I want to do well, let's say this. The top row can get to the Pacific Ocean, which we're going to call 1. The bottom row can get to the Atlantic Ocean, which we're going to call 2. Both of them together we're going to call 3. The left-hand side can all reach the Pacific. I guess that's that one there. Okay. So here, rather than do the max of all of these, what I want to do is neighbors is equal to, hang on. Oh, crap. Is equal to that set. If 3 in neighbors or 1 in neighbors and 2 in neighbors, map row call equals 3. lf1 in neighbors mat row call 1. In fact, no. In this remaining case, is just the mat row call is max neighbors. In fact, we can simplify this here. If 1 in neighbors and 2 in neighbors, we give it a 3. Otherwise, it's the max. If there's a 3 already in there, great. Otherwise, nah. What does that do? Oh, and now my search needs to be for 3s. There we go. That works better. The question is, does this always increase if we're making progress? Yeah, it does. No, that initial logic was good. That logic was fine. It does always go up. As soon as it doesn't change, it will never change. So it must always go up because we're taking the largest thing. Yeah, this is good. This seems good. Let's get rid of the print statements. Run it again, this time without output. I am a little worried that it's a lot of copying and it's sort of an unbounded iteration, but list index out of range. Down. Oh, no, that's correct. What? How can that be an out of bounds? Oh, whoops. That's your problem. Now the question is speed. I don't think we're good enough on speed. Hey, we are good enough on speed. YouTube, don't take that out of context. Fantastic. We're not very fast, but we're fast enough, and that's what matters. Excellent. Quite a neat little problem. I'm still not entirely convinced this was the way to go about it. This kind of wobble until you stop wobbling. It's very APL. So if you know any APL, this kind of problem would be excellent to try and solve in it. It's very good at manipulating matrices. You might... the tricky bit would be how to handle the edge cases. It's much better at rolling at infinite grids, but it's fine. The other tricky bit might be this condition here, but again, I think that should be fairly straightforward to roll out. Excellent. Well, I hope you enjoyed the video. Do remember to like, comment, subscribe, all of that good stuff, and I will see you next time. Bye.